All right, so here are all the questions about this that come with that OpenStax pre-calculus book. Some of them are straightforward because we wrote them down as example problems, or we could think about what would happen. So like just glancing at this, we see a nice even function. It does have a vertical, my gosh, sometimes it takes me a second, a vertical stretch, but we know that that vertical stretch is not going to impact our reflectional symmetry, our even function, but we can always verify. So what we're going to do to verify is we're going to plug in negative x. So that'll be 3 times negative x to the fourth. And no, any negative raised to an even power is positive, so that's just 3x to the fourth, which is f of x. So we get out that this is even. Beautiful. All right, the square root of x. All right, we could, of course, think about what our graph looks like. Hopefully we immediately go, hey, my graph has only got that little arm there. It's not, this is neither. But we could, of course, try plugging in a negative and seeing what happens. We're kind of stuck there. You can't pull the negative out in front of the radical. We know that the domain of this is now completely changed. This is a reflection. So we're now here. That's a terrible drawing, but you get the idea. So yeah, this is neither. Let's move on. Ooh, interesting. We've got a reciprocal function, which does have rotational symmetry. We have a linear function at the origin, which also has rotational symmetry. So do we end up with rotational symmetry when we add them together? Of course, we could jump to Desmos and plug it in, but we can also just algebraically check. Let's plug in a negative x. Get 1 over negative x plus 3 times negative x. We can clean this up a little bit. There's a negative out in front of that. Doesn't really matter if the negative's in the numerator or denominator. We can change that to a minus 3x. Maybe we don't see it yet, so we can take one more step to factor out that negative. And look what we get. We get the original function with a negative out in front, which is exactly the definition of an odd, right? That we get a negative f of x. So this one, adding two odd functions together, does result in an odd function. So let's go ahead and just Desmos this to see what we ended up with. Bring it over here. What? All right, so we can just graph 1 over x plus 3x. And we can see, yeah, sure enough, it looks pretty good. Remember, if we really want to check it, we can change this to f of x equals, and then we could, start playing around. Technically, these should be the same. If I have a negative, or if I have f of negative x, obviously that's going to be the reflection, but that should be the same graph as negative f of x. So as long as the blue and the green, don't even need to actually have the red one show up. As long as this blue and green graph are the same, this is telling me that we have an odd function because f of negative x is the same as negative f of x. The reflection across the x-axis is the same as the reflection across the y-axis. That is my odd function. So that's how you could check these. I won't do the last ones, but you could try them if you want. See if those sort of rules and if your intuition holds, and try using Desmos as a way to check.